Hello everyone, this is SV and Anil Vamsi. We are a team of 5 members joined the Skyfi Labs for the course of tall building design. Now I am going to analyze and design a tall building structure which is having 3 cross-sectional views as shown in here, and I am using the auto select option here in order to make the building most economical depending upon the dimensions required for the different types of loads. The columns are 500 by 500 mm, 550 by 550, 600 by 600, whereas the beams are 500 by 300, 550 by 350, 600 by 400. The concrete I am using M40 grade and HYSD 500 and mild steel of 250 rebars as reinforcements. See the 4 cross sections from story 1 to 8. It is having 3 bays in 2 directions, each of 6 meters apart. Story 1 to 8 are similar and having a dead load of 2 kN per meter square, where the live load is 5 kN per meter square. And the second section, that is story 9 to 14, the dead load will be as usual 2 kN per meter square, but the live load is reduced to 4.5 kN per meter square. Next, coming to the third section, the story 15 to 19, dead load is same 2 kN per meter square, live load 4 kN per meter square. And the final section, story 20 to 23, dead load 2 kN per meter square, live load 3.5 km per meter square, which I am going to apply here. The slabs are 150 mm thick as usual. As already discussed, the grade of concrete is M40. I am going to use the auto draw cladding, which having a load of 0.2 kN per meter on the exterior cladding beams. I am designing the structure as it may be located in Bangalore for consideration of wind loads. See, as I have already opened the ETAP software, so I am taking a new model. So taking units metric and selecting the steel section database as Indian and the steel code IS 800 and 2007, whereas the concrete code for Indian IS 456 2000. So here the spacing, the bay width is 6 meters in both directions, so I am using 6 meters. Total number of stories 23, each of height 3 meters. So here I am using the grid section, but I need to use the similar stories. See here from story 1 to 8, that is one section, so I am selecting story 8 as master story. So now you can assign the similar remaining stories to story 8. Next one, story 9 to 14. So in this way we can assign the master story to the remaining stories for the purpose of similar stories option later, which we are going to see. Next, 15 to 19, So I'm selecting 19. See, the top stories are as usual. Story 22, 23 will be there. Okay. Then okay. Then we will be having two windows. One is for plan section and another is in 3D view. So first of all, I am saving the file. Anil Vamsi. Save. Actually, the main scope of this subject is this project work is to analyze and design the various cross sections of a structure effectively and economically, since I am using the auto select option. As mentioned, we are a team of 5 members. We are from Pace Institute of Technology and Sciences, Ongole. So we have the grid lines as showing here, each bay of 6 meters width. So now I am going to define the material properties, changing the regions to Indian concrete. So we have to consider M40 grade. Okay. Keeping the remaining things as usual. Okay. Add new material again. Now we have to consider the reinforcement, that is nothing but rebar Indian, that is HYSD grade 500. Okay. One more material, that is mild steel for shear reinforcement design, nothing but stirrups. Okay, now we have defined our materials. So we are having a rectangular section, so pick up rectangle. Here the beam sections are 500 by 300, 550 by 350 and 600 by 400. So I am giving B 500, 300 and 40. So the depth is 500, width is 300. Since we are taking the beam in 3, HYSD 500 for longitudinal bars and mild 250 for lateral ties, that is stirrups. Then click on OK. So now I have to take the same section with different dimensions. So I am using the add copy of property, giving B 550 by 350, change the dimensions 550, 350. Since we are making a copy, we don't need to give the reinforcement details again. Click on OK. Then again one more B 600, 400, 600, 400. Okay. Then add new property, again rectangular. Now I am defining the column sections, which are 500 by 500, 550 by 550 and 600 by 600 mm. So C 500, 500 and 40 grade, 500 mm, 500 mm. Now I am giving PM2 M3 design for column, longitudinal HYSD 500, confined bars mile 250. Keeping the remaining same, click on OK, then OK. Now we have the column section of 500 by 500. I am making couple more sections. So since we are using the auto select option, so I am taking a new property. Here you can see the auto select list. I am giving as auto select beam as my name. Selecting concrete sections. Since it is beam, I am taking the beams, then add. Click on OK. Now we have the auto select beam. Similarly, a new property, auto select column, concrete sections, add, then click on OK. Now we have the auto select beam and auto select column options, then close it. OK. Now I am defining the slab section. Add new property, slab 150 mm thick, M40 grade. The thickness is 150 mm. Click on OK, then OK. So we have defined the materials and the section properties, the columns, beams and slabs. So we need to draw the members. So I am using the draw beam column, quick draw columns. So here I am using the auto select column. Since the sections are different with different levels, I am choosing the similar stories option. See, I am at the first floor, taking similar stories. So I am assigning the columns here. See, you can observe only the first 8 stories are got selected and assigned the columns. So I am going to the next level. Select the similar stories, auto select column, okay, assign. Again, make sure the similar stories are selected and auto select column. Similar stories. Finally we have completed. After completion you can click on escape to close it. So I am drawing the beams now. Here select auto select beam. Since I am the first floor, make sure the similar stories are selected. See, you can observe the top 8 stories we are assigned to the beams. Then moving back to top stories. In this way you can assign all the beams. The up and down arrows are used to move to the next levels. So here, then escape. So now we have the beams and column frame structure. So once I am going back to the first floor. Now I am drawing the floors. Quick draw floor option. The slab, we have given the title as slab 150. Select it. Make sure the similar stories are selected. In this way we can assign all the slabs. Repeat the same for the next levels. You have to make sure that similar stories are selected and the property of particular material is also selected. Okay, then escape. So this we can see in extrude manner. See, the frame structure will be like this. I am selecting the ground floor, that is no members are there. I am selecting the joints, restraints as fixed, apply, OK. I am using all stories option. I am selecting the sections. See, you can see all the slabs in all sections are got selected. I am assigning the loads here. Shell loads, uniform. See, the dead load is common in all floors, so I am using the all stories option, and the value is 2. It is in gravity direction, that is downwards. Apply, OK. See, you can verify it is applied in all stories. So now we have to assign the live loads. The live loads are different from different sections, so we have to use the similar stories option. Before assigning the loads, we need to select the sections. See, total 72 shells are selected, that is 1 2 3 4 5 6 7 8 9 slabs, that is 9 shells in 8 floors. So 9 times 8, 72 shells. So now assign shell loads, uniform. Now the load is live. So the first pattern is 5 kilonewtons. I am giving the 5. Apply, OK. See, let's move to next level. Again, (42 shells). Similar stories. Assign shell loads, uniform. Now it will be 4.5 kilonewton per meter square. Apply. Okay. Right. Okay. So we have applied the dead load and wind load, sorry, the live load and dead load as shell loads. We have assigned the columns, beams and slab section. So we need to apply the cladding load of 0.2 kilonewton per meter, since it is UDL, as a frame load at the outer sections. So selecting the similar stories and selecting the outer sections, total 96 frames. 12 leads, 96 frames got selected. Then assign frame loads. Since it is UDL distributed, the load intensity is 0.2. Click on apply. Okay. In a similar way, see the similar stories option is not visible, so we have to go to display and undeformed shape. Now similar stories, all the edges are selected. Then assign frame loads distributed 0.2, applied. Okay. See, if you want to check what the loads are assigned here, previously we have sent the live loads 3.5, so no problem. Put on escape. So now I am using the auto cladding option. Use floors. Okay, see, the entire structure will be like this. Yeah. Now we need to define the wind loads. So go to load patterns, type it as wind, select the type wind, design code is IS875 1987, add new load, modify lateral load, see the wind speed. So we have to check IS875 part 3 for wind loads. Since we are assuming the structure is to be designed located in Bangalore city, see it is in blue color. The intensity will be 33 meters per second. So I am giving the wind speed 33. Now terrain category, see the Bangalore city is located in category 3, so I am using category 3. Then structural class, if the maximum height is greater than 50 mm, the class belongs to C. Since our structure is 69, that will be class C. Keeping the remaining same, click on OK, then OK. So now go to elevation, right? OK, A. Here the cladding loads are showing as UDL. Go to plan, OK. I'm just using the analysis option. Since we have to add the wind loads, so I am unlocking the model which will delete the analysis data, and OK. I have already done auto claddings. Apply. Okay, see the side A will be selected like this. Then select all the shells in A part. See, you can observe here. Then go to assign shell loads. See, you can have the wind pressure coefficients. So now we need to calculate the wind pressure coefficients from IS875. here the ratio of height to width, that is 69 by 18, that will comes under 3 by 2 or 6. So I am selecting this. Then the length to width ratio, that is 18 by 18, that is 1. So I am considering this one. The coefficients are, you can see, plus 0.8, minus 0.25, minus 0.8 and minus 0.8. So in A direction I am using plus 0.8, windward, apply. Okay, but the sections are not, the remaining sections are not assigned, so I am taking the elevation B, apply. Okay, see the remaining sections. Then assign shell loads, wind pressure coefficients, windward, apply. Okay, then again elevation D, apply. Okay, carefully select the shells only. Then assign shell loads, wind pressure. Now the wind pressure coefficient is minus 0.25, that is leeward or sides, so I am using that. Okay, side C, assign shell loads, wind coefficient, apply. Okay, now I am taking the section A1, apply. Okay, see the total shells, 45 shells are got selected. Then I am selecting 2, /61. So in this way I am selecting all the sections at a time here. Then I will assign the loads. Total 122 shells are selected. And shell loads, wind pressure coefficient. Since both the sides are having a coefficient of minus 0.8, I am using it. Leeward sides, apply. Okay. Then I am going to plan section. Apply. Okay. See here, only the outer edges of the structure will be selected, will be assigned the wind loads. See, you can see here. That's it. So we have assigned the structures, we have assigned the properties of the materials, and we have given the members and applied the load. So I am checking the structure. You can use the extrude option here. It is still analyzing the structure. I am unlocking the model once again. See, select all the stories. Then I am running the analysis. So previously we are at 27 meters of height. The analysis will be from 0 to 27. That's why I have unlocked the model. and analyzing the structure once again, selecting all stories. So these are the displacement values here. You can see in extrude option. Now I am going to design. Check it is selected IS 456 2000. Okay. In design. Start designer check. The structure will compare all the sections and all the members for various reinforcing details. Wait until the structure analyzes and designs the structure. It will take some time. See, it is showing that 710 concrete frames are differing, so we need to reiterate since we are using auto select option, so it is taking the next higher level section. So yes, now the structure uses the next higher section of beams or columns, whichever the frames are failed earlier. See, we have got the reinforcing details. You can zoom in here. So the amount of required area of reinforcement here you can observe from top and bottom. So these are the detailing details, reports, project report. You can double click on that. See, the project report will be ready. Whatever the combinations we have taken and the reinforcing details, everything will be in the project report. See here, it will be opened in some other page. You can also verify that all members have safely designed or not. See, all concrete frame passed the design check. So in this way we can design any tall structure. Thank you.